A research colony grows by 20%, then grows by 25%, and finally decreases by 20%. After all 3 intervals, the population is 900. What population did the colony start with?
The word successively controls the entire problem. Each percentage acts on the population at the start of its own interval, not on one fixed original population.
My first instinct is to combine the percentages. Plus 20, plus 25, minus 20. That looks like a net increase of 25%.
That shortcut would work only if all 3 changes use the same base. Here, the first growth changes the base for the second growth, and the second growth changes the base for the decrease.
So I should translate each percent change into a multiplier. A 20% increase keeps 100% and adds 20%.
Exactly. The 25% increase becomes 1.25. Multiplying by it means keeping the current population and adding 1/4 of that current population.
For the final 20% decrease, we keep only 80% of the population entering that interval, so the multiplier is 0.8.
Let P represent the population before the first interval. Apply the multipliers in chronological order and set the final result equal to 900.
Before solving for P, I want to understand the combined multiplier. 1.2 times 1.25 is 1.5.
Then multiply 1.5 by 0.8. The product is 1.2, so the entire 3-interval chain produces a 20% net increase.
That already disproves my additive shortcut. It predicted a multiplier of 1.25, but the actual multiplier is 1.2.
We can keep the calculation exact with fractions. The 3 multipliers are 6/5, 5/4, and 4/5. Common factors cancel, leaving 6/5.
So the original equation simplifies to 6/5 times P equals 900.
To isolate P, multiply both sides by the reciprocal, 5/6. 900 divided by 6 is 150, and 150 times 5 is 750.
Let me verify every interval. Starting from 750, a 20% increase means multiplying by 1.2, which gives 900.
Next, increase that 900 by 25%. Multiplying by 1.25 gives 1,125.
Finally, keep 80% of 1,125. The result is 900, exactly the final population in the prompt.
There is also a useful backward method. Begin at the known final population and undo the changes in reverse order. First, undo the 20% decrease by dividing 900 by 0.8.
Then undo the 25% increase by dividing 1,125 by 1.25. That returns to 900.
Last, undo the first 20% increase by dividing 900 by 1.2. We arrive at 750 again.
The reverse order matters. Just as undoing a sequence of moves starts with the last move, reversing successive percent changes starts with the third interval.
And notice why a 20% increase and a later 20% decrease do not cancel automatically. The decrease is taken from a different, already changed population.
My reusable strategy is turn every percentage into a multiplier, multiply in time order, and divide the final amount by the combined multiplier. Or work backward by dividing in reverse order.
Both methods give the same initial population. Before the first interval, the research colony contained 750.
The final population of 900 is 6/5 of the start, so the start is 900 times 5/6. The answer is 750.